Hi everyone, this is MathsForUni. This is the worked solution to question 10 from lecture 6. If you find this content helpful, then please consider liking and subscribing. And also check out our Udemy course, of which the link is in the description. The question says, what is the value of the square root of 3 plus the square root of 3 plus the square root of 3, all nested inside one another and then off to infinity? It asks us to prove this formally using sequences, which I've spelt incorrectly. Here's an extra S. The hint is to set up an inductive sequence, i.e. an equation relating the terms of the sequence xn plus 1 to xn. In order to get a sequence from this infinite recursion of square roots, we can start with a sequence that looks like x1 equals the square root of 3, and then x2 equals the square root of 3 plus root 3, and then continuing on in the same way, x3 equals the square root of 3 plus the square root of 3 plus the square root of 3, all nested inside one another, and then continuing on in the same way. The limit of this sequence will be the thing that we're looking for, i.e. the square root of 3 plus root 3 plus root 3 plus ... all inside one another. And so, to determine the value of this number, whatever it is, we should write down a relation for the above sequence and then find its limit, demonstrating that the sequence converges to this limit. The relation would be of the following. We would have the next term in the sequence, xn plus 1, would be equal to the square root of 3 plus the previous term in the sequence, xn. And then we'd need to specify that x1 would be equal to the square root of 3. If you can't see how this works, then please write out a few terms of this sequence using this definition. You'll find that you recover the above terms that we wrote down. And so the limit of xn will give us this value. Now, it's worth mentioning that this is an example of an inductive sequence, where one term relates to the next indirectly. We also need to specify the first value of the sequence, otherwise the sequence wouldn't be uniquely determined, i.e. if x1 were instead 1 here instead of root 3, then this would give an entirely different sequence. Now, if this sequence converges to a limit, then we can find this limit by setting xn equal to x and xn plus 1 equal to x as well, and then solving for x. This method works for any inductive sequence, as long as it converges. So, in order to find the limit of this sequence x, we need to solve the equation x on the left-hand side equals the square root of 3 plus x. If we square this equation and rearrange, we get x squared minus x minus 3 equals 0. If we apply the quadratic formula, then we get x equals 1 plus or minus the square root of minus 1 all squared minus 4 times 1 times minus 3, and then all of that divided by 2. If we tidy this up, then we get 1 plus or minus the square root of 13 divided by 2. Each term in the sequence is positive, and so we would expect the limit of the sequence to be positive as well. Hence, if the sequence converges, then we would expect that xn, the sequence, would tend to 1 plus root 3 over 2 because the minus value is actually negative. Now, if we want to demonstrate that this sequence actually converges to this limit, then we need to do more work. All we've done so far is find the value of x such that if this sequence converges, then the sequence must converge to this particular value of x. But this is conditional on the fact that the sequence converges. We won't discuss this at length in this video, since it's beyond the content presented in the video from our Udemy course. However, one possible method is the monotonic sequences property. This says that a bounded and monotonic sequence converges. We discussed what bounded means in our previous example video, but monotonic just means that the sequence is either entirely increasing or entirely decreasing. This sequence is certainly increasing because we start with the square root of 3, which if this term was not here, we would have again, but we add on a further root 3 inside, and this continues on to x3 and so on. Overall, this means the sequence is increasing, and therefore it is monotonic. Now, we can also show that this sequence is bounded by induction, which we leave as an exercise. The main point of this video was to show off that you can find the limit of certain numbers of this form by formalizing it as an inductive sequence like this here, and then setting the xn and the xn plus 1 equal to x, and solving a corresponding equation. If you've enjoyed this video, then please consider liking and subscribing. And also check out our Udemy course, of which the link is in the description. Thanks for watching, and goodbye for now.